Hi again. In this video I'll continue practicing how to detect errors in C++. I will use LLDB debugger. For this example I will compile my program manually without makefile using this line when we have our debugger flag and all the warnings and sanitizer. Okay, our code was compiled. It confirmed that this is not compile time error, it's runtime error. And we have this mentioned here as well, that this is runtime error. Store to null pointer of type in. We have to take a closer look what the error is. The signal is caused by a write memory access. The address points to the 0 page. Let's run with the debugger, break into the main, run the program, and let's check in a GUI. We have our program. This line we assign our pointer to the null pointer. It means it will contain the address of 0. The thing is that this address 0, it's not belongs to our program. It's reserved by operating system. We can access it, but we can't dereference this memory because we are not authorized to do so. That's why when we step to the next, we have a bad access. We had an error on this line. We are not allowed to do that. I have another reference for this thing. It's very crucial to understand that we are not allowed to dereference null, because it's this chunk of memory belongs to operating system. The address 0 is reserved by operating system. We have several options how to handle that. Option 1, we can allocate a new memory for ourselves, and we can save this data to this memory and delete and clean the memory. The second option, check before dereferencing, and dereference only if it's not the address of 0. Option 3, point to valid variable. The main points from that: null pointer points to nothing, and valid address points to allocated memory. Dereferencing rules can dereference to valid addresses, cannot dereference to null or garbage addresses. So for our example we will use option 1. We will allocate a new memory. Let's quit our debugger. Let's allocate for this pointer new memory, and now we can dereference this value to this memory. This is our memory, but after that don't forget to delete the pointer when we're done with it. Every time we have a keyword new, we have to have a keyword delete. Let's recompile. Now we have value of 42. We don't have a segmentation fault. Let's look at the debugger as well. Break in main, run. Let's check on the GUI. So we created a new memory. We allocated memory for this pointer. This is the address of this pointer, and we assigned this value with 42. That's it. See you in next section.